Hello everyone, this is Phil Merlo here at Spot Imaging. I'm accompanied by Patricia Fergal and Robert Giles, and I think on the line is Kent Smith, as well as our associated reps that are around the country. And what we're going to do is just wait maybe a little bit here for a few more people to maybe sign on if they're late. And in that time, we can talk about a couple of things that maybe our housekeeping that we're going to be talking about. And so what we're going to do is record the session, and then we'll be able to send you a link. That way, if one of your colleagues were not able to attend, you can always pass it along to them. Secondly, while the presentation is going on, we'll be muted, and what we'd like to do is have you please type your questions into the chat box, which is in the bottom of that control that's part of the meeting that you're running on. And at the end of the meeting, then we'll have a question and answer session. We can, play around on the microscope a little bit more with the cameras, answer any of your questions there. And then finally, if there's things that we can't get to, we can definitely set up another meeting with your lab by itself and give you demos, or if you need more or you're going to the next step, we can come on site with demos, etc. So that's what I think we'll be doing there. So Patricia's giving me thumbs up. We're going to go to the next and get started here today. And what we're going to cover today is really looking at what makes a great microscope camera. And what we're going to cover is, the fact that it has to fit your infrastructure, your current microscopes, your network, your IT systems. A second thing is streamline pathology workflow, that it's designed for pathology and not designed to be a toolbox for research applications. Third thing is we're going to cover some of the key features for still images. Then we'll move on to the key features that are typically great for live images. And then we'll talk about, and during those sections, we'll actually show you the cameras and go through some of the features that are there. Then we'll transition into just talking about the whole specification, installation, and support process that Spot can provide you. And then further, the overall integrated pathology portfolio and how your different imaging tasks can be completed, as well as integrated together to provide a full imaging support for all the different imaging tasks you have. So let's get started with still image capture. And the first thing I want to talk about is microscopes, field of view, and support on the microscope. And Spot Imaging is historically built and designed and built, manufactured optical adapters that allow you to put your microscope and camera together. We make basically a bottom section of the adapter so that it goes into all the common microscopes that are out there, as well as we have solutions for legacy microscopes. The top part is actually the magnification and C-mount generally, and the top part is made with the finest semi-apple glass of highly corrected, and it actually sets the magnification so that what you see through your eyepieces will fit on the chip of the particular camera that you have. So that's why whenever we do these quotations and setups, we generally want to see your microscope, and we then make sure that we can match to your microscope, as well as provide you with a magnification in the optical adapter to get your field of view so that you can see good fields of view. Next is your IT network and shared drive storage. We don't just leave you with kind of a hanging go use the save function. We build an auto save function into our softwares. These allow you so that when you capture an image, you automatically save that image. That way you never lose the image. And we support basically setting to those root drives and making sure that you can put that out on your server, into a cloud resource, whatever you need to do there. Then the next thing is live preview. All of the spot cameras support WYSIWYG. And what does that mean? That means is what you see is what you get. And that way, the preview is truly a preview. You're not actually looking at something that doesn't have the right color or, the field of view, etc. What you're going to see is what you're going to get. So you can be very happy with it. Next, we provide auto exposure with profiled settings for bright field, dark field, fluorescence. We even have settings for what we call shiny glints. And so that's if you're doing something where there's a big area that you want to just totally ignore. And the case for that is actually if you're on a multi-headed scope and you have the illuminated pointer, it often messes around with most cameras' auto brightness features. And so what we can do is put your camera into either a small shiny glint or a medium shiny glint and ignore the pointer and make sure that we're exposing on your specimen. Additionally, there's correct color. What you should know is that every camera uses obviously a physical sensor, and on that physical sensor they have to use real world filters and dyes on each little pixel down there, and they are not perfect representations of how your eye actually sees color. And so what we do is we capture the raw image. It's okay, but generally it's not hitting the colors that you like to see through your eyepieces. So what we do is we actually perform a color remapping using something called ICC color profiling. And that's the International Color Consortium. It's an international standard. It's built into the operating systems to support this. And what we do is we go in and we set it up so that it does the best job on all the typical stains that pathologists see. And that's why, everybody says the spot colors are spot on, and they're a really good solution. Next thing is resolution. Depending on what you're trying to accomplish, you can go from low-end resolutions where you're just trying to get a dirt cheap camera on a microscope to give a basic representation of what you have there, to ones that really perform. We have the 12 megapixel, it's actually 12.3 megapixel camera. It has very high resolution. We'll pick up the smallest details, and generally those are details you want to see in your mid magnifications like 20x and 40x, which are very common with the pathology applications. Low graininess. I don't know if you've ever seen some cameras, they're just struggling and they're giving you this kind of a grainy image. It's not kind of naturally smooth in what you see through the eyepieces. And generally that happens for two reasons. One is that the camera is built off of a kind of a low grade chip, and it's got a lot of noise in it. And secondly, they're possibly turning on lots of gain, which actually amplifies the amount of noise in the image, and that tends to give you kind of a snowy look to the image. A third reason is that they may then also be jazzing up their post-processing to give you a really punchy image, people call it. It's like a little bit oversaturated, tends to be. And what happens is when you're putting on all these extra operations, you're going to magnify the noise and kind of bump it up in the process. So we really, use a philosophy of, the what you see is what you get. We're not going to over-process your image. We're going to give you a very realistic image. If you want, you can always go off and put it in some other program and beat the heck out of your image. But we generally want, I call it like free-range images. We don't want to have them too processed. Next thing is corrected final image. I'm sure most of you are aware of and have seen in the past where you look at an image then you start to look at it a little bit more and you realize, hey, the corners on my image are kind of dark and they're tapering off. And this is actually quite common in most camera captured microscope images. It's just a factor of how the sensors are gathering their light. There's something called micro lenses on the chips, and in the corners, the light hitting those corner pixels, the light's coming in at an angle, so there's a drop off in sensitivity due to that. The illumination itself, even though your eye doesn't detect it, there's a little bit of fall off towards the corners. And so what happens is that you can actually set up what are called flat fields that automatically correct the image and will smooth that out electronically. So we actually, look forward to using those things. And then finally, when we talked about everything, it's the auto save function again. Everybody would like to have a great image, but if it takes you half of a day, we would never get any of our work done. And so having things automatically done for you, like the corrected final image, the auto save, the corrected color, the auto exposure, the live preview happening very quickly for you, all of these things together make your workflow fast, so that if you have to start adding images to reports that maybe you weren't doing before, you don't have to stay an extra hour or two late each day just to accomplish the task that's been put upon you. For still images, we have a series of cameras called our IDEA cameras. One other great thing is your computer connection is a USB 2.0. So that means that every computer out there, you just plug the thing in. It's a single cable. It provides both the power and the data transfer right to the camera, so you don't have a mess of separate boxes on your desk with extra cords and cables everywhere. Second thing is the microscope field of view. These generally, the optical adapters provide you with a 15 to 16 millimeter diagonal field of view, and you should note that your eyepieces are typically providing you a 21 to 23 millimeter diagonal. The live preview on this is what you see is what you get, so we check that box. It's auto exposure, so we have profiles. The way this one works is that it periodically pauses the image, recalculates an exposure, and updates for you. So it's generally updates its exposure every about 2 or 3 seconds. Then you have color correction. It does that. It has the ICC color correction. Resolution. On these cameras, we have the 1.3, 3, and 5 megapixel. So we have a choice from getting something that's just an entry level to something that day in and day out can do the work you need to do. Low graininess. Basically, this camera works quite well, and it's gain levels of 1, 2, and 4. And once you get past 4, it starts getting grainy. So it's not a camera designed for doing low light or fluorescence work. Corrected final images, it already does the flat fields. That's built into our software. And once you take your image, as long as you select the objective, you'll get the flat field correction. And with the streamlined workflows, we can set you up with either Path Suite, which is very targeted at pathology, or our entry-level software of Spot Advanced or Spot Basic. Those can be set up to at least give you the auto exposure and auto save, which will save you some time. The key to this system is that it's got an excellent price value. Cameras themselves starting out at $1,299 for the 1.3, going up to $3,299 for the 5 megapixel. And when we add in the couplers, installation, and software, depending on what software package you get, it can range from about $1,999 to $4,999 for kind of a highly dressed out package with installation and whatnot. So what I'm going to do is pause here on our presentation, and what we're going to do is show you a little bit of live imaging with the IDEA camera. And I have slide here, and we're going to run this under the PathSuite software as one part of the demo, and then we'll run the Insight camera under the Spot software so you can see kind of the difference in the software also while we're in our demonstration here. So I'm going to go down to 5x. So this is our PathSuite software interface. What you see is it's got a capture button, it's got the magnification setting button. This is important for setting both the calibration and those flat field corrections. You have an offset here for brightness control. Down below is where you set the white balance. You can turn on and off this bar over here for focus. And you can see as I go out of focus, the bar goes down. As I come into focus, I set it, and you hit a high water mark, which I set, and then when I move away from it, it stays up there for a minute, and then it jumps back down. So I can push it back up, go past focus, and then back up to the highest focus. Next, you can go into full screen mode, so if you have to do a presentation or demonstration, you can get rid of your toolbars and whatnot. In addition, we have a magnifier that you can put on the image, and then we have basically the workflow starts off with barcoding in or typing in the case. I don't have a barcode reader on here, so I'm going to put in just a case number here, and you can see that if there's images already on the case, they will start showing up. So you can have grossing images as well as possibly some other microscope images. And I'll snap a 20x image, and then flip in my condenser. Sorry about that. So, and then I would snap an image there, and that is now added to my image film strip. And then over here are tools that allow me to manage these images. I can cut an image, I can add an image to the clipboard, I can duplicate an image. But if I want to work on an image and add annotations or anything, I just click on my image. I now have my image up here, and I have all my working tools over here. I can turn on let's see, let's make this thicker. I can set the thickness of my lines, and I can set the size of my fonts. I'll make them both a little bit bigger. I'll go up to the 48 and say okay, and turn it off, turn it back on. So you can actually, I put a little calibration mark on there. I can grab something and put measurements on. I can automatically put words on, like a different color than that. So I'm going to change that color, and I will get rid of the last one, and I will now put that color on. The other thing is, if this is our text stamp, if you want to add things to your text stamp, you can easily go in and just add a new word to the text stamp, like her2, and say add, and then I'll put PR, oops, type into the thing, PR, and I'll put in ER, so that you have commonly used words in there. And at that point, I can just go back over here, and if this was my her2 image, I can go get my her2, which I probably should have been capitals, but that's that. So this is really the PathSuite software interface for microscopy. It very much mimics the grossing, same interface, but slightly different controls. So, and then the other thing we have here is, when you have a captured image, you can zoom in and walk around on the image. Okay, so that's the IDEA series cameras. I'm running this one with a 0.5x, and this is on a Zeiss scope right now. So I think that's pretty much on that one. And so I'm going to close that out, and then we're going to go back to the presentations and talk about live imaging. So with live imaging, we have all those other great features generally with our cameras, and then what we do is we add other key features, and one obviously is frame rate. The previous camera runs typically in a deprecated live mode, so it's about half the vertical and horizontal resolution, and the 5 megapixel still only running at about 8 frames per second. So it's not very good for basically the frame rate that you want to do in a presentation. You can get away with it in a pinch, but generally for day in and day out use for presentations, we would not recommend it. The next thing is global shutter. The IDEA cameras are a lower cost camera and sensor, and they use something called a rolling shutter. And if you start looking at whenever you move the slide, it looks like the samples gets all wavy or wiggly, looks like it's doing a hula dance sometimes. It's another thing that annoys a lot of people for live mode, is that if they're doing a lot of presentations to a big group, they don't want their images to be kind of wavy. So you'd like to get the global shutter, and so we like to select for that on our live imaging cameras. The next thing is a fast and continuous auto exposure. So what you would like to do is have so that when you change objectives, you're not having to wait around multiple seconds for the exposure to catch up. You want something that's going to change its exposure, nearly as fast as you have changed the objective. You want something that's like in the half a second or 3/4 seconds, typical update on the exposure time. So that's important. Another thing is in real time, you actually want all these color corrections, and that's a hard thing to do, and many companies don't do that. They give you kind of a raw image. For example, we've seen the Optronics 4K cameras and their HD cameras. They're giving basically raw data out, and they're just relying on the color corrections that they have built into their color filters. So you would like to actually have a system that actually uses the power of computing to do those color corrections right on the live image. And then finally, a series of mouse-enabled controls. While you're in live mode, you like to be able to oftentimes pan and zoom in and pan around and basically bring into focus, especially on presentations, or let's say you have a slide review that you're looking for concurrence, and you have several doctors there, and you're using that instead of a multi-headed scope. You want to zoom in on what you really want to talk about, and as well as use your cursor. So having live digital pan and zoom is very important. Exposure adjust is another neat thing on live images. Often this is important on rapid on-site evaluation consults because you'll get clumps of cells together that are diagnostically critical. And what you'll want to do is oftentimes center them, zoom in on them, and then brighten them up so that you can see what's going on in the structure of those cells. So that's also capable. Live measurements, you may be in a tumor board, you get questions about, I'd like to see distance to margin, and I've heard many pathologists say, wow, it really missed me off that the radiologists can do that all the time. I wish we had that feature. Well, you do now with spot cameras. You can pop in and we'll demonstrate that, the distance to margin. To be able to seamlessly be in live mode, and then to just with a right click go out and browse to captured images. They may be your grossing images, they may be other reference images you want to bring up. You may be in a teaching situation where you have students there, and you can have a nice fluid discussion that allows you to kind of browse out, come back to the live images, and you do this all through the mouse. It's not like I got to go over to a control box or do anything else. It's all very interactive. So we have several different accounts that's one of the things that they really enjoy about the new Insight series cameras. And then finally, you can capture images, as well as when you open captured images, you can actually, just using the arrow keys on your keyboard, basically walk through the images and kind of do a slideshow. So if you want to, do, kind of a imaging slideshow that has all the power of zoom in and measure and all those things, you can do those things also. So if we look at this, we have the Spot Insight series of cameras, and they are benchmark cameras in the marketplace. We've looked at all the specs, and most cameras don't have a few of these, basically capabilities. So live modes, we have both their full resolution, which is the 12.3, as well as the 5 megapixel. But oftentimes doctors don't like that dark bands on the side when they have the square image up there, and they'd like the image to automatically fit to the screen that they're presenting on. And they're either presenting on 1080p HD monitors or projectors, or now 4K projectors. And not only that, they want them at the full high-speed resolution and frames per second. And so we have a single button we push, it puts them into those modes, so it matches your monitor, and basically it's oversampled. Our 5 megapixel is actually giving you a 3.6 megapixel resolution, which 1080p HD is typically only 2 megapixels, so it's oversampled, and yet it's running at 67 frames per second. Our 4K is oversampled. It's providing about a 9.3, I think, megapixel, whereas 4K is normally 8 megapixel, and it's running at over 30 frames per second. Generally, we see it running at about 33 to 36 frames per second. These all work off of the fact that you have a modern computer and the power of it, and because we actually use all that computing power to be able to provide these high speeds. Next thing is the global shutter. These cameras have a global shutter, which means every image is shuttered, every single pixel, all at the same time, and that's what gets rid of that waviness. They have continuous auto exposure. Generally, we're seeing less than 3/4 of a second, less than a half second update when you switch between objectives. They're fully color corrected in live mode using ICC color corrections. And enabled on the mouse are the zoom pan, exposure adjust, the measure, the browse and open images, and slideshow. So as well as they have all those other very good things that we have in the captured mode, such as, from what we talked about on the IDEA camera, they have the upgraded USB 3 that allows them to do these high-speed imaging. The microscope field of view is actually boosted up to 17.2, 17.4, and then we have a couple couplers that can get you to 20 millimeters field of view. They have the live preview, obviously, because it's a fantastic live. They're running the auto exposure. They're doing the correct color we talked about. The resolutions we have on the Insight are the 5 megapixel and the 12.3. They're a very sensitive, very nice camera for noise, and so you can go all the way up to gain 16, and that's when you're starting to see the graininess start coming out on these cameras. So they're very, very fine quality images. They do fully corrected flat fields when you capture the images, and they again are supported by the Path Suite and Spot softwares, depending on what software package you purchase. Pricing is quite excellent. $4,950 for the 5 megapixel, $7,990 for the 12.3 megapixel. And comparing that to like these Optronics cameras, which for a 4K camera, they're charging over $16,000 for the setup. So we can easily compete with those. And on installed systems, adding the coupler and the software and installation, you can be somewhere between $5,750 up to about $9,750. So good value cameras. So what I'm going to do now is show you, and I'm going to show this one in the Spot software so that you can see a little bit of the difference of the software. And we'll start the software here. So that's at the 10x, and I'm going to go up to, I guess, 20x here. And when we talk about, the live, you can see this. And to better show all this, I'm going to right-click over here and go into the full screen mode. And we talked about digital zoom. You can see that I can just zoom in and walk around in the live. This is, as you can see, I'm in the live mode. So that's very easy to do and accomplish, and can really accentuate your presentation. This is at the 20x. I'll go up to the 40x here. Great colors, very live image. I'll show you, get out of the full screen. And we're running at right now 30 to 31 frames per second. And that's so when we're doing the fit to screen. If we want to, we can actually change this out, because maybe you would like to see the whole chip. And so we'll go to the full chip mode, which is the 12.3 full resolution. So that's the full chip. You see, you get the black bars on the sides. If we want to measure something, we drop into here, and I'm on the 40x. And I can do a straight line measurement from one location to the other. I'll just make the size of the font bigger. Let's go to 72. There we go. And then when you want to get rid of them, you can just go back into measure and delete all, and they're gone. If you capture the image, it will actually save whatever your measurements are if you want it to. Additionally here, if I would like to, I can, using my controls on the mouse, you see I'm zooming in and panning around. I can grab on the image and just, move it around if I want to walk around the image. The other thing is I'm holding down on buttons on my mouse, and you can see I can adjust the brightness, and then I'll just click down on the scroll wheel, and I go back into auto exposure. I'm going to swap out objectives. You can see how quickly it adjusted its brightness. And so the brightness is always keeping up with me. And then that's at the low power focus. Okay, so I'm gonna go back up to 40x. Lastly, if I want, I can just snap an image, and as well as I can then go out and open images. So I'm gonna open an image file, and I'll bring in some gross images. So, and then just using the keyboard commands, I can walk through my images. And on any image that I stop on, I can go ahead and use all my regular tools, basically show, various other images. So these are our grossing images. And then to get back out of full screen, I can just pop out. And those are the images that I had up there and I was showing. So, and then to go back into live, I can just click the live mode, go back into it, and I'm go back into full screen if I want, and go back to matching the monitor now. So I think that's kind of an overview of how the software works, how the cameras work. And now I'm going to go back to my presentation just shortly and talk a little bit more about support. So, this is all great, but if you don't plan for and don't have support for installation, in other words, review your application, review your infrastructure, fill out your IT security documentation, provide you with computer specifications to make sure that you can use your computers and have them up and running, configure the system, give you a quotation, get your approval, receive your purchase order and give you a confirmation, and then do pre-install planning, which we basically have a questionnaire and we work on whether you're going to primarily do it virtually and have your team set it up, or have one of us come out and set up your system. We go through all that to make sure that you can have a very uneventful, as much as possible, installation and setup, and get you some preliminary training, make you dangerous with either virtual local installer, and get everything set up. And then basically we do follow-up training, after you've gotten your feet on the ground, and you can ask more detailed questions, and we can show you solutions at that point, either virtually or on site. The other thing that we have is we're moving over to software as a service program. Benefits of this is you get a lower initial price on the software, and the other thing is that you have a defined budget item then on a yearly basis to make sure that you're supported and the software supported through basically, if you need IT department support under this contract, you'll get that. You'll get user tech help desk support. You'll get software patches for bug fixes, as well as it addresses interface conflicts between us and maybe the LIS system. You get the software updates. As we release new features, you automatically are getting those, as well as we all know, Windows OS updates come, and you don't have to buy a whole new set of licenses. You automatically get that update, and you don't have to wait for it to get it through a budget cycle. The other thing that we have is not only do we sell, obviously, microscope cameras, and for each of the different applications, such as frozen section for surgical support, or rapid on-site evaluation for cytology support, sign out, with capturing diagnostic fields of view. But we also support grossing for all these applications through autopsy. We support with our own dedicated now teleconferencing system. We support remote imaging, and coming up in the beginning of the new year, we'll actually be launching our new SQL database interface to do more detailed and more extensive auto storage of your images and management of your images, as well as we have the LIS interface, so you can easily port the images for your reports into the LIS. Lastly, if you're adopting camera systems from Spot, you're not, you by far are not the first, nor the least here. And this is a small part of our list of different locations that we're working with and have equipments installed at. So at the end here, I'd like to just hit on a final note, the Spot strengths. Basically, we have professional images because we are image specialists. This is what we've been doing for 53 years. We save you time, money, and space because we really focus in on streamlining pathology workflows. We fit your current infrastructure, your microscopes, your grossing hoods, your LIS and EMR systems. We allow you to do incremental adoption, so you can do microscopes this cycle, and you can do rapid on-site evaluations and frozen section, and then you can do your grossing department and your autopsy. We have solutions for all of those, and they all tie together. We have solid experience. We're actually going on 53 years now. And then system support. We have wonderful people like Patricia Fergal here, Robert, Tina Pavarti, or Proventi, I always say her name wrong, Kent Smith, as well as our engineering staff, myself, are all here when we have issues, and we take care of them. So what we'd like to do now is maybe start covering questions, and we have 15 minutes, so I think we can answer anything that should come up. So the question is the Insight camera sufficient for doing fluorescence? The Insight camera is, and we have several installations that are using the Insight cameras for fluorescence and bright field. So the great thing about this is that the Insight camera actually uses the latest Sony, what's called SCMOS or scientific CMOS sensors. And Sony's gone to great lengths to improve them. And the interesting thing about that sensor is that there were industry shootouts, for OEM contracts, and Sony actually had multiple camera manufacturers introducing both the SCMOS camera and the previous generation CCD camera, which they had the two benchmark sensors there. And in nearly all the applications, the SCMOS cameras were winning the day. And we were actually in the middle of a design cycle with their latest and best CCD camera. And when we started hearing about this, we actually killed that camera design and then switched over to the SCMOS camera designs. And so that's the Insight cameras we have, plus we have a dedicated fluorescent camera called the RT SCMOS camera. So for example, we have generally for renal pathology, we have several different sites that are using the Insight 5 and 12 megapixel cameras to capture both the fluorescence and then easily switch over and do bright field imaging.
Question, we are not able to run Spot software on Mac OS 10.15 or Mac OS 11.0. Plans to support these OSs?
So at this time, we're in the middle of a design and development project that has all of our programmers tied up, which is the PathSuite 3 launch. Once we finish with this launch, which is right now scheduled to launch in the first quarter of the year, that's when we'll be able to release resources to do the update for the Mac, the Spot Mac software. The workaround that we have right now, that allows you to, support the Spot cameras on the newer operating systems, is that if you get Parallels, which is a program that runs a parallel version of the Windows operating system, Windows 10, on your Mac computer, then what we can do is install the Spot software on that and run it under the Spot software. Also note that PathSuite is not designed to run on the Mac at all, and there's no plans currently to move to the Mac platform with the PathSuite software. So right now, our solution is basically Spot Windows version running 5.6, Spot 5.6 on Windows 10, running under Parallels on the Mac system. The thing that you end up dealing with at that point is that the frame rates are not, they're about 1/4 of what you can get if you're running on a full the normal operating system, because that's a virtual operating system. So a couple other things that have come up, and I can just bring up in this area while you're possibly adding some questions, is that the other thing that we've seen is that with our series of cameras, they're all of our cameras are USB 3 now or USB 2. And we've seen that with the update to Windows 10, people are coming across issues with their Olympus and other branded cameras, as well as Olympus still with their DP74 series is using a great big PCI plug-in card. They have not upgraded to this, to the new standard USB 3. Our 12 megapixel can easily compete with the DP74, and we'd love to show you it competitively. And with our line of cameras, we're pretty sure we can compete very competitively with our Olympus, Nikon, Leica, Zeiss competitors to cover the full gambit of different pathology solutions you may come across. Okay, we got about 10 minutes left before the end of the hour. I guess, is there anything else that you'd like to see under the microscope or on the cameras? Okay, so what we'll do is start wrapping up here, and what I'd like to propose for the attendees is that we're going to be sending out a follow-up with the link and answers to the questions that were posed here. But what we'd also like to do is come out and visit you at your facility. And so I think the regional managers and the reps will be in contact with you, and we can bring the cameras out on site because nothing's like having the cameras on site and being able to see a demo. So on your microscope, and we can generally do that. Okay, so we're going to wrap up the seminar at this point, and we'll be signing off. And we would really like to see anybody who we can, because we love doing imaging and we love showing you our cameras. They're the best.